is there a relationship between number of moles and volume? Another word, what is relationship between these two? So Avogadro studied these, and of course, these are experimental studies. So we're starting here on the left with 1 mole of a gas, which has a fixed volume. And the volume is 1 liter. The amount of the gas is, I beg your pardon, and amount of the gas is 1 mole. We are doubling the amount of the gas. We measure the volume. It's 2 liters. Now we are keeping the pressure constant. So pressure is P1 here. This is also the same as P1. We are not changing the pressure. So what Avogadro observed is this. Guys, what do you see? Do you see doubling number of moles is going to increase the volume proportionally? You double one, the other one is doubled as well. So what is the ratio? If I calculate the ratio of V1 over N1, do I get 1 over 1? 1 mole over 1 liter. And if I do the same thing here, V2 over N2, do I get 2? Looks like I'm making a lot of mistakes today. I apologize. 1 liter over 1 mole. And V2 over N2 is 2 liter over 2 moles. I can divide both sides to 2, and you're going to get 1 liter over 1 mole. So do you see these two ratios are remaining constant? So Avogadro concluded that the ratio of volume to N remains the same before the change and after the change. So we doubled number of moles, the volume was doubled. So let's see if I can apply this rule, where the ratio of volume over number of moles remain constant. This is when we change the pressure constant. We don't change the pressure. So if this is the question, 0.75 mole of helium gas occupies the volume of 1.5 liter. That means we have N1 is 0.75 moles of helium, and it has a volume of 1.5 liter. The question is, what would be the volume if we use 1.2 moles of a gas? So this is N2. Sorry, go back. Okay. So just apply this formula. Can I say V1 over N1 is equal to V2 over N2? So all I have to do, plug in the numbers. 1.5 liter, that was V1. Number of moles of gas was 0.75. And then we change number of moles to 1.2 moles. And what is the new volume? So all you have to do is solve this equation for V2 and go ahead, try it and see what you get. What is the answer for V2? You can stop the video, do the calculation, and then turn it on. And do you get V2 equal to 2.4 liter. If you did, that is correct. You are correct. So if I go to next slide, I'm going to define a term for you. And that term is called standard temperature and pressure. So standard temperature and standard pressure, we are defining it just for this chapter, just when we are dealing with gases and gas laws. The standard temperature is 0 degree of Celsius, which is the same as 273 K. And what is the standard pressure? It's defined to be 1 atmosphere pressure, 760 millimeter of mercury. So if I say we have a gas at STP, standard temperature and pressure, immediately make the assumption that temperature is 273 and pressure is 1 atmosphere or 760 millimeter of mercury. That's our definition for STP, standard temperature and pressure. Temperature 273 Kelvin, pressure 1 atmosphere. And I go to next slide. This is why I defined STP for you, because of this experiment. If you take 1 mole of any gas, doesn't matter, it's helium or oxygen or nitrogen, any gas, 1 mole of any gas, under the standard temperature and pressure, it is experimentally proven that it will have a volume of 22.4 liter. So 1 mole of any gas under the standard temperature and pressure is going to have a volume of 22.4 liter, just experimental result. So I can call 22.4 liter as molar volume of any gas under STP. So I'm going to use this information in solving problems because it's an experimental fact. If I go to next slide, guys, do you remember in chapter 2, we learned that if you have any equation, 1 mole is 22.4 liter, and this is at STP. That's what we just said, right? This is an equality. It's an equation. 1 mole, 22.4 liter at STP, or every 22.4 liter of any gas is 1 mole. If this is an equation, do you remember we said whenever you have an equation, you can write 2 conversion factors. 1 conversion factor says every 22.4 liter of any gas under STP is equal to 1 mole, or if you have 1 mole of any gas under STP, the volume is going to be 22.4 liter. So these are equal to 1. These are conversion factors that I can use to convert number of moles of any gas to number of liters. Of course, that is at the standard temperature and pressure. Or if I give you number of moles of any gas, you can calculate the volume if that system is under STP. So now you have 2 conversion factors that you can convert moles to liters or liters to mole under STP. If I go to next slide, let's see if you can answer this. Please stop the video. Think about question A and B. And can you guess what is the correct answer? Is it 1 or 2 or 3? All right. Now, are these the correct answers? I am giving you grams of methane You already know how to convert grams to moles. How do you do that? You cancel grams by writing grams on the bottom. You write moles on the top. That will convert grams to moles. And then next step, you want to cancel moles. And you write moles on the bottom. You want to convert to liter. You write the fact that at STP, 1 mole of any gas is 22.4 liter. By using this conversion factor, you have converted grams of a gas to volume. And in part B, excuse me, we are giving you the volume and asking you grams of helium. Again, both of these are under the standard temperature and pressure condition. So first, you can cancel liter and go to moles. This is the conversion factor we just got, we just learned about when we studied gases at STP. Once you have number of moles, you can cancel moles by writing moles on the bottom and converting it to grams by writing grams of helium in 1 mole of helium. So the unit is left is grams. That's what problem was asking. So you have converted 8 liters of helium under standard temperature and pressure to its mass, which is 1.43 grams.